All right, the next thing we need to talk about is percent dissociation, and it's exactly what it sounds like. It's really easy. It's just another step, and sometimes they ask you this. Instead of asking pH or some other question, you just have to know how to do this. So, as you know, any percent is just a part divided by a whole times 100. So for percent dissociation, we're talking about acid or base dissociation. So the part of that is the amount dissociated. The whole is the original concentration. And then you just multiply by 100 to get the percentage of that. So as usual, we'll do an example or two. And so here we go. So the question is, what is the percent dissociation of 1 molar acetic acid? It'll have to give you a Ka. It's probably going to make you do the calculation. It's not going to tell you what's dissociated, but we can do that. We've done it a bunch of times. So I'm just going to do my ice chart. So acetic acid is CH3COOH, and it dissociates into the acetate ion and a hydrogen. I start with 1 molar of the acid and none of the ions, minus X plus X plus X. So you know how to do this. And so this is what my ice chart looks like. So I'm going to solve for X to find out how much of this is broken down into those ions. So my Ka is 1.8 times 10 to the negative 5th. That's equal to X times X, which is X squared over, I'm just going to try it as 1. I'm going to try to ignore that X and see how that works out for me, because I don't like to do the quadratic equation any better than you do. So what you end up with here is 1 times 1.8 times 10 to the negative 5th equals X squared. So I'm just going to take the square root of 1.8 times 10 to the negative 5. And I get 0.00424. Actually 0.0042. If I look at that and my original concentration is 1, that's 0.42% of what I started with. So hint, hint, that is percent dissociation. But I don't have to worry about the X. That's just my quick check of that. So to find percent dissociation, the part that's dissociated is 0.0042 molar. My original amount here was 1.0 molar, so that makes it pretty easy, times 100, and so 0.42% is my percent dissociation for this one. Now, again, not too bad at all. But I want to look at one more. Same reaction, but this time I've got 0.1 molar of the acetic acid, and there's a reason I'm doing this. We'll see it here in just a second. So let's run through that calculation again. So I've got 0.1 molar to begin with, 0 and 0 of my 2 ions. I'm going to lose X concentration here. I'm going to gain X in both of these. And so, again, same Ka, 1.8 times 10 to the negative 5 is equal to X squared over 0.10. So if I multiply through by 0.1, that's 1.8 times 10 to the negative 6th equals X squared. Back to my calculator. Oops. Raise it to the 0.5 power is the same as taking the square root. So I get 0.00134. So percent dissociation, 0.00134 divided by 0.10 times 100. I do it on my calculator because I mess up my decimals sometimes if I don't. 1.34%, and again, under the 5% rule there. So the reason I wanted to do this is a lot of times on the AP exam, they'll ask this question or they'll want to talk about this. What's the relationship between the original concentration and percent dissociation? So if you look at the ones that we just did, if we have a 1 molar solution, we got a 0.42% dissociation. If we have a 0.1 molar solution, we got a 1.34% dissociation. And so this trend will continue. You can do more calculations if you don't believe me. But there is a relationship here, and it is actually inverse. So the higher the original concentration, the lower the percent dissociation will be. Excuse me. And of course, the opposite of that is true. You could say it the other way. The lower the original concentration, the higher your percent dissociation would be. Now, that's confusing sometimes, and I think the reason I like to ask this on AP is it kind of goes to if you really understand what we're talking about here. In this particular instance, I am going to have more of the ion present. This is going to have a lower pH. It's going to be more acidic. 0.0042 moles is more than 0.00134 moles. But the percent of the original that's actually changed is what we're talking about here. So again, there's an inverse relationship between original concentration and percent dissociation. So guys, that's all I've got for this topic. You're going to do a few practice problems, try this out. I don't think it'll be too difficult for you. The worst part about it is the ice chart, and you guys are taking off with that and doing just fine. So I will be talking to you soon.